Hello, Algebra 2 students. It's Miss Peltier, and today we are doing our 19th session for our COVID journey, and we are going to be doing some logarithmic functions. Yesterday we did exponential functions. Logarithmic are very similar. They are the inverse of exponential functions. So let me just go through with you real quick and help you remember what inverse means and see what a logarithmic function will look like, okay? So an inverse is simply the reflection over the xy axis, or if you think about it, we're exchanging x's and y's. So it's just a difference in notation, and in the next couple of units we'll talk about what that difference looks like, but we're just going to strictly look at just the graphing for a moment. So in our graph from the other day, we did 2 to the x, and when we filled in our chart, we had 0, 1, because 2 to the 0 is 1, 1, 2, 2, 4, and 4, and 3, 8. And I'm going to be going kind of quickly because I don't know how much time I'll have. I want to make sure that I can get through everything. So negative 1 is 1/2, negative 2 is 1/4, and negative 3 is 1/8. So when we graphed that, we went through 1, 1, 0, 1, 1, 2, 2, 4, and 3, 8. And then 1/2 and 1/4 and so on. Okay, so this is what our exponential graph looked like. Now, when we talk about being an inverse reflects over the line y equals x. So when we say the line y equals x, and I'm going to do this in a hot pink color so you can see that line, and I'm going to do it as a dashed line because it's not part of our graphs. Y equals x, remember, goes through the origin and has a slope of 1. So there's my y equals x line. So not only does it reflect over y equals x, it also, we learned with inverses, the x's and y's are switched. So if my x's and y's are switched, when I go over here to do my y equals log base b, notice I have a base b here and I have a base b here, and we read this y equals log base b of x. Basically what happens is we take these x and y values from our exponential function and they're just switched. So this would become 1/8 and negative 3, 1/4 and negative 2, 1/2 and negative 1, 1, 0, 2, 1, 4, 2, and 8, 3. And notice when I graph those, if I graph, I have 1, 0, I have 2, 1, I have 4, 2, and I have 8, 3. I also have 1/2, negative 1, 1/4, negative 2, and so on. So as you can see, when I connect these, it looks as if I folded my paper over, that it would land right on top. Also, you learned about reflections, that it should be perpendicular to your line of reflection. So notice this is perpendicular, this point is perpendicular to that line of reflection, this point to this point is perpendicular to that line of reflection, and so on. So this being our y equals log, and this is a subscript b of x, and our original being y equals 2 to the x. Sorry, this would be our subscript of b would be a 2. Okay, so your bases will be the same. So this would be log base 2 of x is what we graphed. Okay, now one thing also I want you to notice, remember before our domain was all real numbers and our range was always y is greater than 0. over here, what happens when we reflect, now I have an asymptote that is a vertical asymptote. It's this y-axis. So now my all real numbers becomes part of my range. And my domain becomes, notice, only the x values are greater than 0. So those switched as well. So basically everything switches, okay? So I'm only going to get through probably another 1 or 2 examples. So just to refresh your memory, same thing as we did before. The A represents the same thing. So if you need to look back on yesterday's notes, you can refresh your memory on that. Your H does the same thing, horizontal shifting, and your K does the same thing, your vertical shifting. All right. So let's look at this example, because notice we've got several things going on. So my basic function, and I'll do it in the same green that I did up there so that to help you keep it straight, I have log base 2 of x. That's my basic or my parent function. So that goes through the point 1, 0, 2, 1, 4, 2, and 8, 3. Dash line, because it's really not our answer. Here's a half and here's a fourth, and we get close. So let's look what our graph's going to do. Remember, the 2's inside touching the x, just as before. That will be our horizontal shift. Goes opposite, since it's minus, we're going to be going to the right, and we're going to go 2 units. Okay, so each point moves to the right 2 units. 1, 2, 1, 2, 1, 2. I could move that one over, and this one would be here. Remember, we have a vertical asymptote, so it will also move over 2 units. So when I draw this in, I'll draw it in as a dashed line because it's not part of my answer. It's just one step or one shift in that direction, in this case, the horizontal direction. And now we're going to go with our -4. Our -4 gives us a vertical shift. We follow our sign, so we know we're going to be going down 4 units. So I go back to my orange. That's the last one I left off at. I'm going to move every point down 1, 2, 3, 4 units. 4 units. 4 units. And 4 units. Now I could draw it in solid because I've done all of my shifting, and that's what my answer will look like. Our domain and range, remember we have to name those. Our domain this time is not all real numbers. We don't go any to the left of 2, so those are all greater than 2. So we're going to say x is greater than 2. Our range, however, goes all the way down, and it could continue all the way up, just not very quickly. We'll say all real numbers. So that's the things you're going to have to be able to identify is from the equation, find the graph, find the domain and range. All right. Now let's look at our other 2 examples, and let's see. These are kind of about the same. Let's do this one together, since we've got all this stuff going on with a minus and everything else in there as well. Okay. I may have to pull down to get to the rest of the graph, but we'll be all right. Okay, basic function, log base 3. So my function will be y equals log base 3 of x. That's what I'm going to start with as my parent function. So log base 3, I'm still going to be at 1, 0. Now instead of going to 2, because my base is now 3, it's going to be 3, 1. And then we would have to go all the way to 9 to get to 2. Because remember, it's just opposite of what we had before. And our -1 would be a 1/3. So here's my basic function if it were log base 3. All right. So for my changing, If we have a number in front, which we do, we have this -2. That's going to be our vertical stretch by a factor of 2, and we're going to reflect over the x-axis. All right, so vertical stretch. If you're on the x-axis, it doesn't go anywhere. It's going to stay there. But this point, that is 1 unit away from the x-axis. When I take my y value of 1 and I multiply it by 2, I get 2. 1 times 2 is 2. Then I reflect it, so it becomes -2. When I take this one that's at 2 and I stretch it, it would go to 4. So when I reflect it, it would come down here to -4. This one here that is 1 unit away, when but it's negatively, notice when I multiply it by 2, it makes it a -2, but then when I reflect it over the x-axis, it comes up here to be -2. And so there is my new graph. And hopefully you can see how it is reflected over the x-axis. Exactly like we did with our exponentials, it's just you have a different starting point, okay? So if I do my inside, my x, my 4 tells me we have a horizontal shift opposite the sign, so we're going to be going to the left 4 units. So each point will go 1, 2, 3, 4 units. 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 Notice also that vertical asymptote shifts over 4 units, so I actually have a vertical asymptote here. I could draw that in. Oh, this is a dashed line because we're not at the end. And lastly, we have our -3, which is our vertical shift. And we're going to go down, follow the sign, 3 units. So when I go down 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. It kind of goes off the screen for you, sorry. This one I will make solid because that is my final answer. So there's my graph, my domain and range. My domain, x values, the smallest we get is -4. So we're going to say x is greater than -4. And we'll say our y values are all real numbers. Okay. Now again, I will not have time to finish the other one during this recording, so I will go ahead and finish it to post it with the answers or the key, if you will, for the notes. If you want to practice the example 2, you'll be able to see how the example 2 works and make sure that you got it right. Remember, in your work, all these dashed lines, I don't need to see all of that. The answer is the solid, but for me and for my visual people, it helps us to see those lines so that we can see, oh yes, am I going in the right direction? Because sometimes just keeping up with the points is an awful lot, okay? So if you have questions, jump on your teacher's Google Hangouts. They'll be more than glad to help you. And send us a message or an email and let us know if you have anything that you need us to work out for you, if there's anything we need to do. All right? So y'all stay safe and be careful, keep in touch, and we hope to see you guys again soon. Bye.